S rotation, rotation, and polar motion. So how do we do that? We have a vector of coordinates of points in CTS system, so the conventional terrestrial system, and with some rotation matrices. If you remember, it was like that. R2 is the rotation around the y-axis, and X is the rotation around the R1 is the rotation around x-axis, and R3 is the gas angle. You come to CIS coordinate system. So the position of the satellites, actually, they are given, if they are given in these two systems, the position of the stations and the system, you can compute these 3 parameters. So a guy with name Monta in 1984 gave a formula for laser measurements, which connects actually the coordinates of the satellites and the changes of the range. So the parameter is this one, U, is argument of latitude, as far as I remember, is for the orbit, right ascension, and the lambda and phi are connected to the coordinates of pole. For example, I will write it here. D, the differential of phi, so as you see here, all the parameters of the Earth rotation parameters, the polar coordinates, the coordinates of the pole, and this is gas. Gas is in fact Greenwich appearance to the real time. So if you can, by changes of this laser data, the laser ranges, you can see the changes in these parameters, this S rotation parameters. So if you have many of this, the S, for example, over an arc, you can make a system of equations and estimate these parameters, the rotation parameters. So it's the rotation rate, the gas, the changes of that you can measure, and you can also measure or determine the coordinates of the pole. So that's one way to determine the S rotation parameters using SLR data.